You ever look at someone and just wonder how their mind works? I'm talking about those people who can just intuitively get these incredibly complex rule-based systems. They don't just learn the rules of the game, it's like they can feel the entire structure. Well, today we're diving into a really fascinating new blueprint for how these minds might be wired. It's a theory that could reframe how we think about expertise itself.
So what is it? What's the secret sauce that makes a pattern master? Is it just thousands of hours of practice? Or is there something fundamentally different going on in their brain, a whole other cognitive architecture? That's the big question we're going to unpack together.
I mean, think about a chess grandmaster. When they look at a board, they are not seeing 32 little pieces. No way! They see forces, they see structures, they see these deep strategic patterns playing out. They can recognize thousands of board positions in an instant and just know the right move. It's pure intuition.
Or, hey, what about the prolific coder? They navigate these massive libraries of logic and syntax, but they're not painstakingly remembering every single line of code. It's more like they feel the flow, the architecture of the whole program. They can just see the elegant solution hiding in all that complexity.
And this isn't just for, serious fields. Look at a Minecraft architect, someone who can build these insanely intricate systematic worlds out of simple blocks. In all of these cases, chess, code, Minecraft, the structure and the outcome are totally reliable. You place the piece, write the code, or put down the block, and the result is logical. This is where they thrive.
So, how do they do it? Well, the theory we're digging into today proposes this really cool idea for a cognitive engine, a brain that basically operates like a massive, super-organized lookup table. All right, so this theory puts two ways of learning head-to-head. Most of us, we have what you could call an interpolation brain. Think of it like a calculator. It learns general rules, the formulas, and then applies them to new situations. It's great at seeing the big picture, the forest. But the lookup table brain, or LUT brain, it's totally different. It's more like a giant phone book. It's obsessed with storing thousands and thousands of precise, specific examples. It sees the individual trees with unbelievable clarity, and it builds its whole understanding from the ground up, one concrete data point at a time. Now, this learning style, it has a very specific signature in behavior, monotropism. And we're not just talking about having a hobby here. This is an intense attention tunnel. It's a tendency to funnel pretty much all of your cognitive resources into one or maybe a few areas. This deep, immersive focus, that's the engine that fills up that mental lookup table with the gigantic number of examples it needs to become a master. And that mastery is built through a process called chunking. So, a novice looks at a chessboard and sees 32 separate pieces. I mean, that's just overwhelming, right? But as they learn, they start chunking pieces together into patterns that actually mean something. The master, though, having filled their lookup table with thousands of games, they don't even see the individual pieces anymore. They instantly recognize these huge, complex strategic setups as single chunks, pulled effortlessly from their long-term memory. And get this process physically changes the brain. An expert's brain isn't necessarily more active, it's more efficient. Believe it or not, it actually prunes away connections it's not using, which can sometimes mean less gray matter in certain spots. It even repurposes whole brain regions. For chess masters, the part of our brain that recognizes faces gets hijacked to instantly recognize chess patterns. The key takeaway here is the shift from slow, careful calculation to lightning-fast, intuitive pattern recognition. But there's a catch. There's always a catch, right? This highly specialized cognitive architecture, this thing that's so incredibly powerful under the right conditions, it's also incredibly vulnerable. Its entire development hinges on being in a stable, predictable, and responsive environment. So if this powerful system is so vulnerable, what happens when it doesn't get what it needs? When that stable, predictable input it's craving just isn't there? Well, that's what we're looking at next. The absolutely devastating cost of neglect. Now, to really get what happens next, we have to draw a clear line between abuse and neglect. Abuse is an act of commission. It's something harmful that's done to a person. But neglect is different. It is, like the quote says, a catastrophic act of omission. It's the absence of the essential stuff, the stimulation, the care, the interaction that a developing brain is desperate for to build its model of the world. So for a brain that's trying to build a lookup table of the world, this complete absence of information is just disastrous. The consequences are real, they're measurable, and they're severe. The brain's white matter, its communication highways, they get all disorganized. The prefrontal cortex, which is kind of like the brain CEO, can actually show reduced volume. And the whole stress response system gets thrown into total chaos, creating a biological memory of that trauma.
And we can see this with incredible detail. This table shows exactly how damage to specific white matter tracts, the brain's wiring, links directly to problems we can see. So when the superior longitudinal fasciculus gets affected, you see issues with attention and language. Damage to the cingulum? That messes with emotional regulation. The brain is literally being starved of the patterned input it needs to form those basic chunks for healthy development.
Okay, so all of this, it leads us to a really profound new way of looking at this whole concept. We're not just talking about a set of strengths and weaknesses. We might be looking at a fundamentally different human blueprint.
So here's the big idea. What if this cognitive architecture isn't a flawed version of a typical brain, but instead it's a highly specialized system in its own right? A system that's biased toward bottom-up processing, deep, systematic thinking, a system that's perfectly adapted for certain kinds of environments.
The implications here, wow, they are just staggering. Research suggests that the genes tied to this cognitive style are ancient, and they've been under their own unique evolutionary pressures. One mind-blowing theory is that these genes might have slowed down our brain's development after we were born, and that longer developmental window, that could have been the very thing that created the space for complex language and abstract thought to emerge. So this specialized mind might not be an outlier. It might be a key part of the evolutionary trade-off that made us human in the first place.
Which leaves us with one final big question. When we look at this architecture of the mind, are we seeing a disorder that needs to be fixed? Or are we seeing a unique human blueprint that needs to be nurtured, supported, and just profoundly understood?